Yeah, I'm just gonna give a brief overview first, and then we can like deep dive into the topics once we like ask questions on top of it. Um, that is hmm, interesting. Okay. Yeah. Um, okay. Yeah. Today's topic is based on the L1 networking, mostly be uh, okay. Right. Okay. Let me just try to give a brief overview of what the landscape looks like. There's a great video, I would say, by Adrian Manning from Lighthouse on this very topic. But like, I just like I didn't know how vast this topic is, so I have just briefed out all the important points here. So basically, we can like divide the networking part into like three domains, or probably the phases, I would say. There's the discovery part, and there's a gossip part, and then there's a request response domain. Um, so the discovery part mainly focuses on s- basically trying to find peers once a node basically connects to the blockchain. Right now, it uses diskvify where there are some boot nodes, and then from boot nodes you get some peers, and then you can do ambient peer discovery over there. Uh, like there's the Disqui 5 is a whole another topic where we can see how the protocol works. But yeah, I'll just like skim through everything, and then maybe we can come back to uh, the discovery part. This is so then there's the gossip part, which is, I would say, the most crucial part of all of the networking. So gossip uh, started up with out with flood sub, where basically each and every peer just sends message, and that those peers just send to their peers. uh, it's very easy, and the message dissemination rate is very fast. Like um, all the peers in the network can get the message almost instantaneously. But there are there's other factors, something called message amplification, which is a huge thing to consider, and because of which the whole bandwidth of the network increases. That's one part. And then there are different proposals which try to solve these bottlenecks in different ways. So episub is one, but like based on some simulations like really early in time, it did not like give a significant increment on gossip sub. So that's where like gossip sub came in, and then like it was implemented. I'll just give you a brief overview of how gossip sub works in general. So I think I can use the visualization here. Uh, okay, so here's a great visualization that I found. So basically, let's say there's one.
Honest, we can't see your thing because I believe you shared only one
Oh,
of
okay, okay. Okay. How do I do this? Uh, share, Let me just share this entire window, I guess. Hmm. So yeah. I think it's probably visible now.
Yeah.
So yeah, this is the visualization that I found. It's super nice. So yeah, basically there are subnets within the gossip. So uh, basically, like there is an entire network, and then there is a small subnet where you basically do a flood sub. Uh, so like you get a message and then you publish it in your own subnet. This is like a brief visualization of that. And so you have these topics basically. There are some global topics and there are some subnet topics where like only uh, like the peers in the subnet get those messages and not globally. So like beacon block is basically the global one where each and every node gets the block and then like updates its database, local database, and then like tries to verify if the block is right or not, and tries to so this is for a validator. It submits like a proof, sorry, an attestation that this is right or wrong, the block it has received. Now, like again, coming back to the network bandwidth, there's a trick that is being used uh, in Ethereum would be that like basically there are 12 slots in an epoch. So sorry, 32 slots in an epoch. So what we need is a validator to vote at least like at most once in one epoch. Uh, so basically, what it does is in Ethereum, we use something called BLS signatures, which has a unique property of uh, aggregating signatures. So if you like combine signatures and then in simple words is basically combining the signatures, and then like if you ask someone to verify it, then all of these n signatures are verified basically. So, so basically, what happens is there are committees which are decided, and then there's one aggregator, and all the signatures are sent to the aggregator, and the aggregator basically aggregates the signature and then publishes the aggregate to for the validators to approve basically. So uh, once that is done, the block is validated basically. So this was like the use of the networking layer, I would say. uh, how it is used in the consensus client layer. Now, maybe we can start talking a little about how this all this happens on a local view of the node. So think of it in this way. Basically, the peer does not. It's just a black screen in front of the peer. It does not know what is happening outside the black screen. It just uh, sends and receives messages from its peers. That's all it knows. So basically, the protocol needs to be designed in a way such that uh, uh, a local peer, like the peer, can do all sort of algorithms locally, and then globally it affects such that the network is basically stable. So that's where the peer scoring comes in. So if the uh, if the node uh, basically sees a bad behavior by its peers, it starts down scoring, and then like there is a possible message in the network saying that this peer has been acting bad. So it all the peers start down scoring on that particular peer, and then eventually there is a graft message. I mean, there's a prune message on that peer, and then the peer is just kicked out. So that's one. And then so basically, there's now there's message that needs to be transmitted over the network. That's like so. Gossip Sub uses something called snappy compression on SSG encoding. So all the data is basically encoded and compressed and sent over the network. Uh, and Yeah, so the potential network changes for further folks would be for DAS mostly, because DAS is going to use a lot of network, and I think it's mostly a networking problem. So like right now, what they are trying to do is there's something called peer sampling and there's subnet sampling. Now peer sampling is um, basically just probing for samples in the network, and here again the problem of message amplification is like almost zero, but then it's very brittle because you don't know which peer will give you a sample for sure, or uh, there are some security implications to that. But in subnet sampling, it's just floods up in your own subnet, and then you can just take messages from the subnet. But obviously, there is some sort of message amplification that is uh, implied to that. Um, um, yeah, I think I gave a simple brief overview of the networking part. I think we can deep dive if there are more questions, I guess.
Thanks, Manas.
Yeah.
Any questions from anyone? Okay, I just wanted to understand if everybody understood how the peers connect with each other, or do you understand what ENR is, and how ENR of consensus clients differ from that of execution layer clients?
Uh, oh yeah, for sure. Uh, so yeah, I I did not mention the assumptions I've taken. I've taken a lot of assumptions here because of prior knowledge. So I think I should write down that in my HackMD as well. But yeah,
Okay, that's fine. I mean, uh, y- you guys are familiar, right? Execution layer clients use a protocol known as Dev P2P, which was tailor made specifically for Ethereum. However, when they started to build consensus layer, they wanted to leverage the advancements in libp2p and take advantage of that and build a completely new a P2P stack, which would use all the advancements there, which is what led to the development of DiskV protocol, DiskV 5, which was built. I mean, there have been several implementations of Disk V5 which were purposely built for Ethereum consensus. And I believe as a part of that, they upgraded the ENR, I think Ethereum name record specifically for consensus layer clients, introducing a couple of new fields as well, I believe. Especially because there are over 1 million validators, they wanted to build kind of subnets for certain attestations to avoid multiple message passing or gossiping across the whole 1 million validators. So if you look at, I'm not sure if you've had a look at the enrviewer.com is a website which will provide you an explanation of how an ENR exists. And this particular link provides you a list of boot nodes maintained by each implementation, I mean, client implementation. So you have different boot nodes for execution layer as well as consensus layer. So if I were to say take a particular one from Lighthouse, and I mean, let me share my screen. Where is this? Yeah. So this is the one of the ENRs that I picked from Lighthouse's boot node. This tells you some information about it with the IP address on which it is listening. What is the the port where it's listening as well. And I've noticed there were two separate one called what do you call the attestation subnet and another subnet, but that doesn't seem to show here. I'm not sure. Needed to dive deeper into that to understand how an attestation subnet as well as a sync subnet is assigned to a node when it starts set. Is that dynamic or it changes? It is decided at the start. That is something I've not been able to identify yet. Manas, did you have a chance to discover that bit?
Um,
Or does anybody else? Yeah.
I,
Sorry, go on, Manas.
yeah, I'm not very sure, but I think the subnets are transient. Uh, I'm not very sure about the sync committees. I think sync committees uh, are permanent. I think so. I'm not very sure.
Okay.
Aren't aren't these like subnets like randomized? I mean, like because like sync committees and the attestation is randomized every the attestation is every epoch, right? Then you probably get assigned a new subnet every epoch, I would assume.
I presume that as well, but however, it's part of the ENR. So are we then saying that the ENR
Mm.
changes every slot? I don't know.
I
That's
mean,
what.
they are topic. They are topic that you are subscribing to, and they are hard coded. It's not part of ENR. It's the gossip subtopic.
Hang
And
on.
there are global topics that all nodes are subscribing to. Like if you are running your beacon node, and then you are subscribing to a global topic to hear what proposer is proposing each slot, and there are local subnets. So if you are scheduled to run some certain attestation at certain slot, then you wanna you wanna subscribe to that topic for that slot and participate that subnet.
In my knowledge, ENR can contain arbitrary key value pairs. So the attestation subnet and secret committee subnet can be included in the ENR, but the example shows that the boot node doesn't have to contain all of the information. So I think that is excluded. And aside that, there is a metadata defined in the P2P interface in the consensus specs. It contains the attestation subnet and sync committee subnet also. So the peer can ping or get the information from each other through that metadata, in my knowledge.
Yeah, boot node is just a node that help you to connect to the network when you start your node, and you don't need to connect to boot node after you're already part of the network.
Yes, for sure.
Yeah.
Boot node is just like Kademlia, like I think Kademlia basically has a boot node, and then you just ask peers and then go on with the network.
It's only used when you initially connect to discover peers closest to you. After that, you disconnect from the boot node and you're only peering with the other people that are closer to you. Yeah. Any other questions that anyone else had? Or
I want to add, like, I added the URL just now to the chat. It links to the specs from phase 0 of the beacon chain. And yeah, you can see there's attestation subnets. It's part of the, it's basically a gossip subtopic there. But I suppose that you probably have to know your subnet ID, and then subscribe to that beacon attestation subnet ID. And basically you get the unaggregated attestation from that topic. But how you get the subnet ID that you belong to, I'm not too sure. I haven't digged down.
Yeah,
it's just a predefined rule, a hard-coded rule. So if you look at this link, Prism is using this one. And I'm pretty sure that if you open up other CL repo, you can find similar, this kind of hard-coded source file.
Yeah. So I think like the global topics are hard coded, and then like the attestation subnets are basically transient because that's based on the random, and randomly like you are
Yes.
put into committees and you're supposed to post an attestation. So
Yes, but there are certain patterns, so you want to just follow the pattern to find your subnet topic whenever you need to.
Yeah. Okay.
Yep.
Okay. Do we then move on to the request response, or are there any questions on Gossip Sub or Discovery?
I have a question to Oppenheimer. I remember you shared the alternative for Gossip Sub on the epidemic broadcasting trees. So I read some sentences on paper, but I didn't catch a lot. So what do you think about the replacing the current Gossip Sub model to another Pop Sub model, like tree based on models?
So as I mentioned, right, all these gossip protocols per se have bottlenecks basically. So you either and it's like a balance between all of these. So either you can have like super fast message delivery, or like have a lot of message amplification. So what Episub tries to do is basically one message delivery. Like it tries to have only one message that needs to be delivered to the peers that need the message. But then the problem with that is there is a huge construction just to have that, right? And then it's very brittle. And then like if one link breaks, right, you'll need to apply an entire algorithm to basically rebalance the tree in simple terms. So I think Gossip Sub. I think I spoke with Adrian who did simulation for that, and then turns out that it wasn't that big of a difference as compared to Gossip Sub. So that's why they probably dropped the idea. But now I think someone from Mega ETH is gonna work on the new Gossip Sub for Beam Chain, because like the signatures that are going to be aggregated in subnets, the size is going to increase to almost 100 KB. So now 100 KB being per slot is a lot of work. So that's why I think there's going to be a new sort of gossip protocol maybe.
Would that require a change in Gossip itself? I thought changing the compression from, say, Snappy to something else should solve
Yeah, this is what I was also thinking, that probably changing the compression algorithm would make sense. But I think Snappy does a very good job, and like finding a better compression algorithm might be difficult, I would say. So I think changing the Gossip protocol makes more sense, I guess.
Okay, it's interesting. I'm curious to know how gossiping would improve performance. I mean, Justin is there. Justin, if you can throw some light on that.
Yeah. So on the compression point, like the signatures and the aggregate signatures, they're essentially just random bits, and so you won't get that much compression from the from compression algorithms. In terms of potentially changing to something other than Gossip Sub, basically, as far as I understand, the intuition is that there's a lot of overhead and redundancy with things like Gossip Sub, where a certain peer basically sends messages unnecessarily to other peers. And so what I think Lee Young is working on, he did his whole PhD thesis, by the way, on on peer-to-peer stuff. And one little tidbit that I learned is that Danny Ryan funded his PhD. So this was kind of a complete coincidence when he approached me. I didn't know, and I think what he wants to work on basically is this protocol where there's some sort of a negotiation process or handshake process where the peers determine what they need to communicate before they actually communicate, and that leads to more efficient outcomes. To be fair, I don't know the details of what he's thinking of, and so one of the next steps would basically be for someone to try and chat to him, and if you want an introduction to Lee, I'd be more than happy to make an introduction.
Yes, please. This would also mean then we have, the teams would have to build a new libp2p library that's compliant with the new alternate to Gossip Sub implementation, right? Or is it just going to be an upgrade of Gossip Sub protocol?
Yeah, so exactly. Like if we do go down that path, there would need to be a re-implementation of some equivalent of Gossip Sub. But the good news is that my understanding is that Gossip Sub is a fairly thin layer on as part of the whole P2P stack. So almost all of the stack stays the same, and you just re-implement the highest level of the stack. But
Okay.
you're right, like it is a lot of work because we have 5 or so P2P implementations that would need to be re-implemented. So we would only go down that path if it was really worth it. Another thing that I'll say is that Dankfat has been telling me that he believes there's a ton of overhead at the dank sharding level, and so if we do implement an equivalent to Gossip Sub, then we would probably keep the design requirements there as well, so that we could have one solution for both types of gossips.
Okay. Listen. Thanks for that, Justin.
Just to mention about the finding peer that has the information that I need. So I think in the discovery level, we can utilize or leverage the topic advertisement that I send to the message. I thought that these things is not well implemented in any other clients. It's just like spec. So we can use this to advertising that what I need to the network, I think. Could you give any feedback about this?
You're referring to I want to, right? Sorry, Jun, you're on mute. You were referring to I want to in libp2p, right?
Sorry, can you articulate?
Were you referring to I want to?
Layer?
Yeah, no. The message type, or what do you call that in libp2p? I want to, or is that something else? There is one.
Yeah. I want to. Yeah.
Okay.
Oh,
I
okay.
remember reading some time back. I'm not sure.
I think there are a few proposals by I think Pop from the networking networking at EF. He's suggesting something called announce up. I don't really have the hackmd, but I'll post it once it's up, I guess.
Okay.
That's basically trying to I'm not very sure, but I think it's along similar lines that announcing the basically messages that you want. So
Okay.
I'll share the HackMD. I think I'll also need to go through that, but probably something along that lines.
Manas, can you post your presentation, that link as well in this chat so that it's available for everyone?
Yeah, I'll do that. 1 second.
Okay, question from Anavat. Any takers for that? I haven't come across Wire, so I have no idea.
So just a bit more context. I think I heard in the latest execution client call, all core dev, about the Wire protocol versioning. Like right now, it's probably like ETH 70 or something. And I think that applies to the execution layer. So I wonder if there's something similar for the consensus layer.
No idea.
I guess you are referring to EIP 7639, bumping up ETH 71 from ETH 70.
Yes.
Yeah, but as far as I know, Dev P2P is for EL, and
Yep.
CL is used like they use just different kind of P2P layer.
Mm.
So there's P2P layer for EL and separate P2P layer for CL. So they don't suffer from that kind of necessary to bumping up that version to prevent a network bifurcation, a bipartition because of the pruning all the historical data before the merge.
Hmm. Yeah.
Okay. Thanks.
Okay. Any other questions on the gossip sub? Okay. Manas, you want to go into request response, or were you planning on anything else?
No, I mean, like the request response is mostly the like the negotiation part. I think the most significant bit of the entire networking is probably just the gossip sub and how the data is being transferred between peers. So yeah, that was mostly what I tried to do. I have an exam today, so I didn't realize how big the topic is.
That's fair enough. Any recommendations? I mean, I have looked at. I mean, this is a general question for anyone. Which client implementation would you recommend for learning more about the P2P stack? And
For
what?
Rust, I would suggest Grandine. Uh, Grandine is like, I mean, it's basically just the uh, code conversion of the spec. So it's very easy to correlate between the spec and the code.
Okay.
So, yeah, but then I'm not sure about the implementation. A lighthouse is like considered, uh, but it turns out that Grandine was also performing better. So I'm not sure, but it's a great project. Like it's very easy to understand, like the nomenclature and everything.
Okay. Any other questions from anyone? Anything do you guys want?
I mean, some sort of feedback on the presentation today. Maybe like what sort of things we can like today. I assumed a lot of things, I guess. So maybe the next time, uh, like what sort of discussions do we want to conduct? And yeah, I think that would be a fair topic to discuss.
Yeah, that's a good point. Actually, we last time we had the audience was more limited, so we knew what we were planning ahead. But there have been new joinees since then. Maybe for now, we probably maintain a page which says what is the next topic that we would be studying on, and some pre-reading material probably can be posted there, and people can come back and discuss and ask questions during the session. So what do you think should be the next topic to cover? Do we spend more time on the P2P layer itself? Do you think there are more points that we should probably dig into here and before we move on to others? Or cryptography, I believe there is going to be a change next year, and Justin said that he'll be arranging specific study sessions to cryptography. So whatever we learn for now might not be relevant for the Beam client implementation. So I would suggest we focus on topics that are relevant to the implementation of Beam client in future as well, which are not going to change. So there are different modules within the existing Beacon client implementation which are not going to change when we move to Beam. So if we are familiar with those aspects, we should it should be easier for us when we start building the Beam client. That's my opinion. I'm happy for others to suggest what you would. So, what do you guys think next topic should be? Sorry, Justin, were you about to say something? Are you unmuted?
Yeah, I just wanted to say that I think it makes sense to study the topics that won't change. But if you do want to study some of the new stuff, for example, the cryptography and the internet signatures, I'm more than happy to make introductions to the relevant people, and they might be interested in joining the call as well.
Yes, please. That'll help as well. Just
Also, Justin, like, I think I'm just gonna be candid and ask you a few questions on what should we be doing as a Beam Giant client right now. I see that Zeem is trying to build a runtime, and should we be acting in similar way, or are we doing good with the study groups, or like that's just an open-ended question for you.
Yeah, so I need to basically find a way to. So first of all, I'll say that there's a ton of enthusiasm. There's now 15 different teams that want to build a Beam client, and so I'm still kind of in the process of team formation and also trying to figure out funding and stuff like that. So I had a chance to talk to Trent from Protocol Guild. The Zine team also submitted a grant request to the Ethereum Foundation. So I want to try and find a way to basically be fair to all of the teams and find a good process. I also want to find a mechanism to keep all of the devs engaged. And at a minimum, as you know, there'll be these calls that I want to organize and these Beam days and Beam retreats. Now, in terms of specific things to work on, I think the biggest risk is the aggregation of these larger aggregate signatures post quantum signatures. As you said, like they're 10x larger than BLS, so from 100 bytes to roughly 1 kilobyte. But then the aggregates are much larger. They're on the order of 100 bytes, and so like one of the way forward would be to have a very small number of teams, maybe one or two, just help out with a proof of concept. We don't need too many chefs in the kitchen. Another thing which is just generally valuable is to start kicking the tires of the ZKVMs, so that we can have as much diversity as possible. Ideally, especially for a language like Rust, you can support all of the ZKVMs because you'd be so performant. So that you even support the slower ZKVMs, and it's still early days for the ZKVMs, and their documentation will be lacking. They may not have all of the features such as continuations. So continuations is the ability to basically stitch various segments of the proofs using recursion. They might have compiler bugs and all sorts of tooling issues. So just helping them fix their bugs and building relationships will be helpful. There's some infrastructure like SSD which will be reused, but I guess for Ream that's not an issue because there's already implementations there. Yeah, sorry, I don't have a fully formed answer yet, but long story short is the ball's on my end to try and find tasks to keep the devs engaged while 2025 is to a large extent dedicated to basically writing the specs and and converging fully with the researchers on exactly what needs to be spec.
Okay.
Sounds good. That's a good answer. Cool. I think we'll probably try to start kicking with the ZKVMs. So yeah, I guess.
So yeah,
Recently, I dig into SP1, and it gives some great abstraction to engineers like us to wrap the Rust code into the compiling to the machine code that ZKVM can understand. So I think SP1 or the RISC-0 can be a great candidate, as I mentioned in the Telegram, and also the awesome ZKVM keeps adding the projects about the ZKVM, so you can refer to this. And I'm very interested to these things.
so should we cover that in the next week, or is there any other topic we would like? I mean, just an intro to ZKVMs, not necessarily how it's going to be used in the Beam chain, but general information, because all of us are presumably new to ZKVMs in general, right?
I think we can select either cryptography or ZKVM to feel more friendly to those new tech stacks. Because personally, I have no idea about them, so I'm keep researching and reading the docs. So it will be great to prepare the next year Beam session or Beam days by Justin. Studying the further topics about them. Yeah, so I can suggest the ZKVM and the Winternets because I have no idea on that.
Okay. So we'll
Good
probably
news is that.
Yeah,
Sorry,
go on.
go ahead.
No, go on.
Yeah. So good news is that we have a badass cryptographic engineer here. So Philip, can you share some thoughts on that if you want to go down that path?
Yeah, that sounds like a good idea to me. I mean, I would also be very interested in the cryptography aspects of this, of course, especially the post-quantum cryptography stuff. But I'm not sure if this, as Justin said, this might be a moving target still. But yeah, I mean, I would be down doing that, and yeah, looking into the Winternet's cryptography signature schemes or scheme in general. The ZKVMs also sounds good. I think maybe the ZKVMs, it might be useful to, yeah, as we talked about, do some prototypes and figure out the abstractions and how useful they are and how we can use them. I mean, there's Nexus, there's RISC-0, SP1, and there's also like the name is Powder, right? Which is also an Ethereum Foundation project, as far as I know. So maybe we can already look into this, because this we definitely need, and this isn't like a moving target yet. But yeah, as a next step to, I would be down to look into the post-quantum cryptography stuff. So, and I'm also more than happy to prepare something if that's helpful, and yeah, contribute that way.
So
Cool.
should we do ZKVM first, then cryptography, or cryptography first? Which would you prefer, and who wants to volunteer doing the presentation?
Yeah, so I can maybe add my 2 cents. So maybe we can start with the ZKVMs first, and then I would I mean, I can contribute to the presentation for the Winternet schemes. But yeah, if there's more time, because I also have to look into this because it's a very new topic.
Yeah.
Yeah.
Maybe I can dig into ZKVM, just a brief overview next week. Yeah, I'm studying, so I will give you my shallow knowledge about the ZKVM right now. So yeah, I'm happy to share a presentation next week.
Yeah, and I can.
Yeah, go ahead.
So sorry, yeah, that sounds great. And I can already look into the Winternet scheme, and maybe next week give a quick update, because I'm still traveling through Vietnam, but I'm passionate about this. So I can maybe already start looking into this, and then after that week we can look into post-quantum cryptography and the signature scheme.
Yep, sounds great.
One of the topic that we can deal with is the ISA for the ZKVM, and Justin mentioned in the DevCon, all the things will be based on the RISC-V. So there's a lot of ZKVMs projects with RISC-V or any other like Cairo or other Valida. I thought those things are present. So the next week we can talk about the ISA, about the ZKVM and ISA together.
Right. Would you also be kind enough to share some pre-reading material in that link so that we come prepared for the same setup? I presume
sure.
the same time works for everyone, right? Next Monday then, yeah? All good? Okay. Any other questions from anyone? Or is there anything else that we had to discuss? Yeah, go ahead, Anand.
Yeah, I have a question, and maybe for Justin. So I noticed that you mentioned about the website called ethproof.org, and I assume that that's kind of like a challenge to for all the ZKVM researcher and developers to snarkify the execution layer state and the state transition, right? And kind of like probably like a benchmark website where we can compare with like different implementations and different algorithms. I don't know if that's correct. And if that's correct, do you think it's worthwhile to start thinking about that for the consensus layer? For example, like we come up with like a small, like really small, like subsection of the like consensus layer state, and then we try to kind of like implement a simple like state transition function with different implementations and benchmark them. Would something like this make sense to do now, or any value at all to do that?
Yeah, fantastic question. Yeah, so you're exactly right. ETH Proofs is trying to use the mainnet EVM chain as the canonical benchmark for these ZKVMs. And the plan is actually to launch on December 13th, this Friday. We're hoping to launch with 2 partners, SP1 and RISC-0, but we're in touch with several other ZKVMs that should be launching on the website shortly after. What we're starting with is encouraging the vendors to prove 1 in 100 blocks. So every block that ends in 00. And yeah, we'll be showing key metrics like latency and cost. And there is a Telegram group that was recently created for the ETH Proofs community for anyone who wants to try and contribute. It's fully open source. And contributions are welcome. And there's also going to be some work involved in talking to the long tail of ZKVMs and helping them integrate with the website. Now, as to your question, should we do something similar for the consensus layer? So one data point here is that Grandine has done exactly that. So they've taken one of the consensus clients, I believe it's Lighthouse, and they fixed a certain number of validators. I forget exactly how many, and they tried pushing it through the tooling. And during that process, they actually found a bunch of bugs because it's a heavy workload. So that's part of the kicking of the tires that actually has been super helpful for the ZKVMs. I had a chat with the RISC-0 folks in person because I was in New York just last week, and they were saying that this was the worst experience that they had ever had onboarding someone. Like usually, it's all smooth, but for Grandine specifically, for some reason they caught a bunch of bugs. Now, if you want to take specific other subsets, then and maybe trying language, well, maybe not languages other than Rust, but maybe trying trying more than just these top 2 ZK VMs, I think that could be helpful. One thing that I'll say is that I expect the Beam chain to be orders of magnitude more snark friendly than the Beacon chain, maybe 3-4 orders of magnitude. And so yeah, just because it'll be designed from day one to be snark friendly, I don't expect the same kind of performance issues. Just to give you one concrete issue that I think they found is that the ZK VMs have a limit in terms of how much memory they can allocate, something like 4 GB or 2 GB, something like that. And Grandine was just hitting that limit. And so you need to compile things in such a way or massage things in such a way so that it fits into the limit. Another thing that I mentioned is that not all the libraries are supported by the ZK VMs. So I believe that RISC-0 on a daily basis will run through the top 1,000 Rust libraries and basically tell you which ones are compatible. And I think it's about 70% right now. And some of them will just never be compatible because they do non-deterministic things like, I don't know, networking or randomness or something. But yeah, as the tooling matures, all of the libraries that are compatible should be supported. And yeah, going through the process of trying to compile down to RISC-V and run on the ZKVM will expose like all of these nitty-gritty technical details. I mean, another thing that that's on my head just as a brain dump. There might be opportunities to have a non-deterministic version of the state transition function. So in Snarks, we have this superpower where basically the prover can submit hints. And like the classic example is taking a square root. So if you want to take a square root in plain text, you have to do quite a bit of work. But if you want to verify that you have a square root, it's super easy because you just take the number and you square it. And one of the potential exercises would be to take the existing consensus state transition function and find opportunities to add hints, so that the proving is significantly simpler. And just going through this exercise might be helpful because a similar exercise will have to be done or could be done for the Beam clients as well. Now, on 2 other points that were brought up, June, you mentioned RISC-V. So technically, you can use whatever ZK VM you want. There's no restriction on RISC-V, but like some ZK VMs like Cairo only support very few high-level languages that compile down to Cairo VM. And in the case of Cairo VM, it's only Cairo lang, as I understand, and none of the clients are written in Cairo lang. At least not right now. I think Stockware is actually considering, it's not one of the 15 teams, but they are potentially considering writing a Beam client in Cairo lang just to show that you can actually use Cairo VM for this context. But yeah, this morning I had a call with the ZKM team, and they have a WASM virtual machine, and they should be one of the launch partners. Well, not launch partners, but they should be putting their proofs on eproofs.org fairly soon. And then Philip, on the Winternet signatures, we have someone called Benedict Wagner, who is writing a formal kind of academic paper with someone called Mike. And he's planning to get it done this week or maybe early next week. And so happy to introduce you if you ping me on Telegram, and he can share the paper in advance and maybe also join the call.
Please, yeah, that would be awesome. I'll ping you. Thank you.
Justin, if you could introduce us for that P2P stuff as well. I'm not sure the person's name. Did you mention Young? The gossips. Yeah.
Lee Young. In general, ping me for introductions. Otherwise,
Sure.
I just don't remember that I have to do them.
No, I'll do that.
Thank you.
Thank you. So unless anybody else has anything else to discuss, I think it's nearly time we can end this here. Arjun, please share the pre-reading material, and yeah, let's catch
Sure.
up next week. I'll share the recording later on. Let's keep it within this group for now. We can publish it later on if required. Justin, are you okay with that, or do you want this to be made public?
I don't have a strong opinion either way.
Okay.
Yeah.
All right. Thank you.
Justin, can you share the repository you mentioned about the ZKVM that people talking about, and feel free to contribute. I missed that part.
Sorry, who was that question to, Jen?
To
Me, I
Justin.
think.
Justin.
Sorry,
Okay.
which repository?
You mentioned while talking about ZKVM recently created.
Yes, so it was maybe the eproofs.org website. So let me paste in the chat. Yeah, this is the repo.
Thank you, Justin.
No worries.
All right. Thanks, everyone. Cheers. Have a nice day, everyone.
Sure.
I know.
Cheers. Bye-bye.
Thank
Thank
you.
you. Bye.
Bye.
Bye-bye.
Thank you.